Dear students, today we will learn about the shortage of first preemptive scheduling and non-preemptive scheduling algorithms. I will solve one question and you will understand about the preemptive scheduling and non-preemptive scheduling SJF algorithm. Okay, so shortest job first SJF scheduling algorithm. First part is preemptive scheduling and second part is non-preemptive scheduling. Consider the following example. Process P1, P2, P3 and P4. Arrival time is given 0, 1, 2, 3 and the burst time is also given. It's 6, 4, 2 and 3. Find the average waiting time using preemptive scheduling and non-preemptive scheduling algorithms, SJF algorithm. Using preemptive SJF and non-preemptive SJF algorithm. First of all, I will solve this question using preemptive scheduling algorithm. Preemptive SJF scheduling algorithm. So the arrival time at 0 arrival time, P1 enter into the system. So there is no any other process in the system. So P1 will start to execute. This is the Gantt chart. Okay. So P1 will start to execute from 0 to 1, right? At 1, there is two processes in the system, P1 and P2. So which process will execute now? Because P2 has shortest burst time, so P2 will execute first. In shortest job first algorithm, you will check the burst time. Minimum burst time process will execute first, right? So P2 will start to execute from 1 to 2, okay? Because at 2 another process enter into the system, right? So P1 execute one time, so remaining time is 5, right? And P2 is also execute one time, so the remaining time is 3 now. Now P3 will start to execute P3 and P3 will execute up to one time. So at 3 there is another process enter into the system. So the remaining time for P3 is 1. Now P4 enter into the system. So at 3 time all the process enters into the system, P1, P2, P3 and P4. So which process has the shortest burst time? P3 has the shortest burst time. Okay, so P3 will execute again. P3 will execute up to 4, right? And P3 will exit from the system. Now P3 exit from the system, right? So there is another process, P2 and P4. So which process will execute now? P3 will execute now because P2 will execute now because P2 enters before P4, right? So sorted first come first served basis, P2 you will consider P2. Now P2 will execute up to 7, right? Up to 7. So P2 will exit from the system now. So at 7 there is two process, P1 and P4. P4 has the shortest burst time, so P4 will execute now, okay, and P4 will execute up to 10. Now P4 will exit from the system and there is just one process in the system, P1. So P1 will execute now up to 15, right? Now you will find the waiting time. So waiting time for P1 is equal, in the beginning P1 enter into the system at 0 and start to execute at 0, so there is no waiting time, plus P1 wait from 1 to 10, and start their execution again. So 9 waiting time here, 10 minus 1, right? So the total waiting time for P1 is 9. Waiting time for P2 is equal, P2 enter into the system at 1 and start their execution at 1, so there is no waiting time for P2 here, and P2 wait from 2 to 4, so 4 minus 2 is 2, so the total waiting time for P2 is 2. Waiting time for P3 enter into the system at 2 and start the execution at 2, so there is no waiting time for P3. P4 enter into the system at 3 and P4 start the execution at 7, so 7 minus 3 is 4, so the total waiting time is equal to 9 plus 2 plus 0 plus 4, so total waiting time is 15, right? Average waiting time is equal to 15 divided by 4 because there are 4 processes in the system. So 4 3 is 12, 3.75, right? So this is the average waiting time in preemptive scheduling, SJF scheduling algorithm. The second part is non-preemptive SJF scheduling algorithm. Now construct the Gantt chart again. At 0 there were no any process except P1, so P1 will start to execute up to 6. In non-preemptive SJF scheduling algorithm, P1 arrived at the system at 0. There were no any other process in the system at 0. So P1 will start to execute from 0 to 6 because there is a non-preemptive scheduling algorithm, so no interrupt will happen. Okay, so 0 to 6 P1 will execute up to 0 to 6. Now there are 3 processes in the system, 1, 2 and 3, right? So which process has the smallest burst time? P3 has the smallest burst time. So P3 will execute now. So P3 will execute up to 8. Right? Now the another process will execute. So P1 exit from the system and P3 exit from the system. So there are 2 processes, P2 and P4. P4 has the smallest burst time. So P4 will execute now. Okay, so P4 will execute up to 11, right? Now P2 will execute from 11 to 15. Clear? Again, in non-preemptive SJF scheduling algorithm, you will start from the 0 arrival time. So at 0 arrival time, there were no any other process in the system except P1. So P1 will start to execute, right? So 0 to 6, because this is non-preemptive SJF algorithm, so there is no interruption will happen, right? So 0 to 6 P1 will execute. At 6, there are three processes now in the system, P2, P3 and P4. So you will find the burst time, the minimum burst time. So P3 has the minimum burst time, so P3 will execute now, right? After that P4 will execute, because P4 has the smallest burst time 3, then P2 will execute, right? Now you will find the waiting time for P1 is equal 0, because P1 enter into the system at 0 and start their execution at 0. Now the waiting time for P2 enter into the system at 1 and start the execution at 11. So 10 is the waiting time for P2. And what is the waiting time for P3? P3 enter into the system at 2 and start the execution at 6. So 4 is the waiting time for P3. And P4 enter into the system at 3 and start the execution at 8. So 5 is the waiting time for P4. Now average waiting time is equal to 0 plus 10 plus 4 plus 5 divided by 4. So total is 19 divided by 4. So 4 for 16, 4.75, right? 4.75. So which algorithm is the best algorithm among these two algorithms? So preemptive scheduling algorithm is the best algorithm, because the average waiting time is less than the average waiting time of non-preemptive SJF algorithm. So preemptive SJF scheduling algorithm is better than non-preemptive SJF scheduling algorithm. I hope you all understand this example. Thank you for watching.